What's going on, people? This is Factoring Special Cases. If you are in third block, you must watch the beginning of this video because I made a super duper horrible mistake when teaching you all. It wasn't that horrible, but I'm making a big deal out of it because I've been trying to tell y'all differently. I did not tell you to factor out the GCF. And so I'm going to go over the problems that I did not tell you to factor out GCF. And I'm so sorry, but yeah, and none of y'all caught it either. So thanks, shout out to Jordan Neville. This is probably the only shout out he'll get in his life. So make him feel special. He's probably over there cheesing and smiling, telling myself, yeah. Because he told me that I needed to factor out the GCF, which is what I've been stressing. So these are the two problems I did not factor out the GCF of. We're in the Galaxy. That's our theme today, Galaxy. All right, so when I look at these numbers, I tell y'all, not scream, factor out the GCF, but that was horrible when doing this. So we need to factor out the GCF. So the GCF between 16n squared, 16n, and 4 would be 4, okay? So I factor out the GCF, and I'm left with 4n squared plus 4n plus 1. And now I am to see if this is a perfect square trinomial. If it is, then it can be written as this. So the way we do that, we take the square root of our first term. I'm about to get the answer in here. 4n squared. And the square root of 4n squared is my grad school book has been teaching me that we teach y'all this wrong in the beginning. That's why y'all jack your life up in the future. But this is technically positive and negative 2n. Why? Because a negative 2n squared gives me 4n squared. And then a positive 2n squared gives me 4n squared. Okay, but we're only going to use the positive factors today. But technically, that is correct. Okay? But we're not going to use the negative factor. We're only using the positive factors today for the perfect square trinomial. Okay, because technically that's correct as well. But just shouting that out before we get to quadratics. You need to know it. Okay, whatever. Erasing all of this. So this is 2n, and then we take the square root of 1, which is 1, right? Okay. Okay, and then yeah. I was about to say something else, but I forgot. All right, so now we see if this is A, because A squared, this represents your A squared. This represents your B squared. And this is 2 times A times B is right here. Okay, my arrow looks a little ugly. But anyway, you get the point. So if I multiply these, this is half of this. Yes, it is. So since it's half of this, 2n times 1 is half of this. Half of this. We're looking at this now. We're not looking at the 16. The 16 has been converted into factor out the GCF. So if this half of this, then it is a perfect square trinomial. So we can write this as 4 times the square root of 2n plus 1 squared. Okay. The video taught us this. I messed up and forgot to tell you how to factor out the GCF. Okay. So for this problem right here, the GCF would be 4. Again, so we factor out 4 and we get what? 4m squared plus 12m plus 9. All right, and then we say, hey, is this a perfect square trinomial? Because I see a perfect square here, I see a perfect square here. Is it half of this? And then it will be a perfect square trinomial. Now, in the future, I expect y'all to do some of this in your head. You don't have to write all this out. Square root of 4m squared is 2m. The reason why we're doing that is so we don't forget our variable, because some of us will. The square root of 9 is 3. 2m times 3 is 6m, which is half of this. So this is a perfect square trinomial. So we can factor out a 4, and we end up getting 2m plus 3 squared. All right, box in and circle your answers, Mr. O'Neill. Be an example to these wonderful youths. All right, then over here, we did this. There are no GCFs here, no GCFs here other than 1. And we get here, there are no GCFs here because 5 doesn't go into 16. And so there are no GCFs here. All right, so I needed to stress that because I did those wrong. My apologies. And now let's move on. Difference of squares. So we added a square here, we added a square here, we added a square here, and we added a square here. So when we are subtracting two monomials, which makes a binomial, if we are subtracting, we are asking ourselves, can this be the difference of squares? Is this the difference of squares? You know, that's what we ask ourselves. So when we see two monomials being subtracted, after we ask ourselves, did we factor out a GCF, GCF, did we factor it out? We ask ourselves, is this the difference of squares? And if it is, then let's write it. Now, there is no addition of squares. We will see that later on in another lesson. All right, so x squared minus 4. Again, we did this. We did not do the rest of these over here, but we did do these. And so I'm not going to spend too much on time on this. I'll pick x squared minus 4. Okay, x squared is x squared. 4 is 2 squared. So this is the difference of squares. It's the difference of x and 2 being squared. And we learned that when we FOIL this out, your inner and outer terms will cancel. Your inner, 2x, your outer, negative 2x will cancel. Your OI, your outer and inner terms cancel, and you're left with your first, and your last terms, which is x squared minus 4. There we go. So we come over here, GCF all day, every day, all day, every day. Can we take out a GCF? Can we take out a GCF? So when we take out a 2, here we get x squared minus 36. I see two monomials being subtracted. Subtracted. Is this the difference of squares? Okay, so it is, because it's the difference of x squared and 4 squared. 6 squared, Mr. O'Neil, get your life together. All right, so we have 2. Y'all, I remember when the guy messed up in the video and y'all went crazy. I tell you, y'all have no chill when people mess up. I mess up every now and then, you know, just like I messed up on Friday. Y'all are probably demeaning me, try to take my teacher of the year away, but you can't. I'm still, all right, anyway, let me get focused, because this video can be long if I just get distracted. All right, so here we ask ourselves, can we factor out a 3? And if we can, we factor that bad boy out. So if we factor out a 3, we take out a 3, we will end up getting 49 out of 147. So we can take out a 3, we get p squared minus 49. Oh, I see two monomials being distracted. What is wrong with this word? I'm distracted. Subtracted. Is this the difference of squares? Yes, it is. It's a difference of p and 7 squared. There it is. All right, here, can we take out a GCF? Yes, I know that 3 goes into 15 and 3 goes into 24, and the number is 5. So yeah, let's take out a 3. When we take out a 3, we get 5b squared minus, Mr. O'Neil, there's a b there. Get your life together. Take out another b, 3b, buddy. We take out a 3b, and that is 5b minus 8c. Is this the difference of squares? Well, in order for it to be the difference of squares, these variables must be squared. And since they're not, it's not. So therefore, we are done. That is what that is. Y'all, please don't get confused. If you can't do nothing with it, you can't do anything with it. It's not prime. We factored out a 3b. It's not prime. There is just nothing else to factor out, y'all. Okay? All right. Over here, we can factor out a 6. Somebody's calling me. I'm sorry, y'all. When we factor out a 6, we are left with d squared minus 16. Is this the difference of squares? Well, yes, it is. It's the difference of d squared and 4 squared. Again, it does not matter which one you write first. I can hear my wonderful Anna R asking that. Factor out a 6 here, we get d squared minus what? 3. Is this the difference of squares? No, because 3 is not this perfect square. It is not. Okay, so this is not the difference of squares. It is just this. 6 times d squared minus 3. Y'all help me with my pronunciations. All right. Let's go here. Let's see if 56 is divisible by 4. Let's see that. 56 divided by 4 is 14. So we factor out a 4, and we get 8 squared minus 14. Is this the difference of squares? No. Because 14 is not a perfect square. No, we're done. We're done with you. We're moving on. Okay, let's look here. We can factor out a 7, and we end up with u squared minus 4m squared. Well, is this the difference of squares? Well, u is u squared, 4 is a perfect square, that's 2, m is a perfect square, that's m squared, so yes it is. So therefore our answer is 7 times u minus 2m, just to prove my point, doesn't matter which one we put first, times u plus 2m. That is my answer. Now this last one, I'm debating about. Well, once I show y'all the other video, y'all can get it anyway. So it's not like y'all can be honest about it. So, well, some of y'all won't be honest. So I'll just do it anyway. So w to the 4th and 9. Okay. Well, w to the 4th. If I take the square root of w to the 4th, I'm basically saying, hey, what gives you w to the 4th? That's w squared. So if I take this square root of w to the 4th. Y'all don't kind of know this until math 2, but this is w squared. You can figure that out because w squared times w squared gives you w to the 4th. Okay, and the square root of 9 is 9, 3. What am I talking about? Okay, but it's not a perfect square trinomial, right? Because 3 times w squared is not half of this, right? So we know it's not a perfect square trinomial. So we know that. But can we factor it? You know what I'm saying? Can we factor it? So we know that w times w squared times w squared is going to give me w to the 4th. This is my first term. And we know that factors of 9, negative 9, that add to give us negative 8. Well, that has to be a negative 9 and a positive 1, right? And then look, y'all. I see a binomial that's being subtracted. W squared minus 9 is a difference of squares. So we do w plus 3 times w minus 3 times, come on pen, don't start acting weird on me, times w squared plus 1, and that's my final answer. I was going to leave this for extra credit, but after y'all see difference of squares gone wild, this probably won't be easy. Okay, so that's the continuation of this video. Now you're about to go into difference of squares gone wild. You need to make sure that you understand this. And we know this is not a perfect square trinomial as well, because when we look at the perfect square trinomials, there's not 2 subtraction signs, you know. So another reason why it's not. All right, so I got to do my signature move. About to get on up out of here. It's been Mr. Hold up now. I'm trying to get a highlighter. This thing up here trying to be weird. Highlighter tool, buddy. It's been great. Love y'all. Miss y'all. I'm in Greensboro at this conference doing my thing. You know what I'm saying? All right, we out.